Boron. Boron, an element with the symbol B and atomic number 5, has a rich history dating back to ancient civilizations. Initially utilized in applications such as mummification by Egyptians, it wasn't until the early 19th century that boron was successfully isolated as an element by Sir Humphrey Davy and John Jacob Berzelius, named after the Arabic word for borax. Boron gained industrial importance in the production of glass, ceramics, and soaps in the late 19th and early 20th centuries. During World War II, boron compounds played a role in the Manhattan Project and the post-war era. Boron found applications in the emerging semiconductor industry. Modern uses of boron includes its role as a micronutrient in agriculture, its incorporation into flame retardants, and its application in experimental cancer treatment known as boron neutron capture therapy. The element's unique properties and versatilities continue to contribute to various scientific and industrial advancements. Physical property. Boron is a relatively light element with a brownish black appearance in its most common crystalline form. It has a high melting point and is a poor conductor of electricity in its elemental form. Chemical properties. Boron forms compound with variety of elements, and its chemistry is characterized by covalent bonding. Boron compounds often act as Lewis acids, capable of accepting electron pairs. Allotropes. Boron exists in several allotropes, and the most common forms is crystalline boron. Boron can exist in different physical states under specific conditions. However, it's important to note that elemental boron itself is not commonly found in nature in its pure form, and its common states are usually as compounds. Does it exist in all states? Solid state. Elemental boron exists in a solid state under standard conditions, room temperature and pressure. Crystalline boron has a structure that can vary, including rhombohedral, tetragonal, or orthorhombic forms. Liquid states. Under typical conditions on Earth, boron is not in a liquid state. The melting point of boron is relatively high, around 2076 degrees Celsius or 3769 degrees Fahrenheit, and it typically remains in a solid state at room temperature. Gasol state. The metal boron can be vaporized, turning into a gas at a high temperature. The boiling point of boron is around 3927 degrees Celsius or 7101 degrees Fahrenheit. However, reaching this extreme temperature is not common in everyday conditions. In practical terms, when we discuss boron in various states, we often refer to boron compounds. For example, boron oxide, B2O3, can exist in a solid glassy state or a liquid state when molten at elevated temperature. Uses. Boron and its compounds are known for their diverse applications across various industries. Some of the notable uses and products associated with the boron include glass and ceramics. Boron compounds, especially borosilicate glass, are known for their high thermal resistance. Borosilicate glass, commercially known as PREX, is used in the production of laboratory glassware, kitchenware, and high-quality optics. Agriculture. Boron is an essential micronutrient for plants. Boron compounds such as borax are used in fertilizers to address boron deficiency in soils. They play a crucial role in plant growth and development. Flame retardants. Boron compounds are used in the production of flame retardants. These compounds help reduce the flammability of material and are used in various products, including textile, plastics, and furniture. Semiconductors industry. Boron is used as dopant in the semiconductor industry. It is added to silicon during the manufacturing of electronic devices to modify the electrical properties of a material. Nuclear applications. Boron-10, a naturally alkaline isotope of boron, is used in nuclear reactors. It has a high neutron absorption capacity and is utilized in control rods to regulate the rate of nuclear fission reactions. Medicine, boron neutron capture therapy, BNCT. BNCT is an experimental cancer treatment that uses boron-10. Boron compounds are selectively taken up by cancer cells. When irradiated with neutrons, boron-10 undergoes a nuclear reaction, releasing particles that can selectively destroy the cancer cells. Cosmetics and personal care products. Boron compounds such as borax can be found in some cosmetics and personal care products. They may serve various purposes, including as pH adjusters or preservatives. Metallurgy. Boron is used as an alloying element in production of certain metals, such as steel and aluminum. Barium copper alloys, which may contain boron, are valued for their high strength and conductivity. Experimentation and the DIY application. Can you do it yourself? When conducting experiments with boron or boron compounds, it's important to prioritize safety and follow proper laboratory practices. Here are a few simple and safe boron-related experiments that you might find interesting. Borax crystal glowing. You can create borax crystals as a simple and safe DIY project, dissolving borax in water and allowing it to crystallize can result in beautiful crystal formations. Materials needed: borax, water, string, pencil, container. Procedure: create a borax solution by dissolving borax in water. Suspend the string in the solution using a pencil as support. Allow the solution to cool overnight and the borax crystals will form on the string. Frame test with boron compounds. Boron compounds can be used in frame tests to observe characteristic frame colors. Material needed: boron compounds, example borax; flame source, example Bunsen burner. Procedure: dip a wire loop into boron compound, borax well. Heat the wire loop in a frame and observe the color of the frame. Different elements emit characteristic color and the boron may produce a green frame. Borax slime. Material needed: borax, white glue, water, food coloring. And this is optional. Procedure: Mix water and borax to create a borax solution. Mix white glue with water and food coloring if desired to create a glue solution. Slowly add the borax solution to the glue solution while stirring. Observe the formation of borax line. Borax as a pH buffer. Material needed: borax, vinegar, baking soda, pH paper. Procedure: dissolve borax in water to create a borax solution. Test the pH of the borax solution using a pH paper. Add vinegar or baking soda to observe how the borax solution acts as pH buffer. Safety tips: always wear appropriate personal protective equipment such as gloves and safety glasses. Work in a well-ventilated area or use a fume hood when dealing with boron compounds. Follow proper waste disposal procedures for any material used in the experimental. If working in a school or institutional setting, adhere to safety guidelines and regulation. Remember that even seemingly simple experiments should be conducted with care, and it's important to be aware of potential hazards associated with the material being used. If you have any doubts or concerns, consult with a knowledgeable instructor or expert before proceeding. Safety consideration: toxicity. While boron is essential element for plants, excessive exposure can be harmful to humans. Proper safety precautions should be taken when handling boron compounds. Inhalation hazard. Certain boron compounds may pose an inhalation hazard, and adequate ventilation and protective measures should be employed when working with them. As with any chemical, it's important to follow safety guidelines and exercise caution when working with boron or its compound, especially in DIY setting. Always prioritize safety and consult reliable source for proper handling procedures.